Hello, my name is Yukari Sugiyama from Yale University Library. Although many of you know me as a Japanese cataloger, my job actually changed 3 years ago. I'm the librarian for discovery and metadata assessment now, working in the areas of metadata consultation, workflow automation, data analysis, and visualization. Today, I'm going to talk about how automation can help speed up library work, especially in the area of cataloging, as technical services departments are doing a lot more work with fewer staff and less money. Even if you don't do this kind of work yourself, the automation programs I developed and will introduce to you today were inspired from my experience as a Japanese cataloger, so I hope you find this presentation relevant and helpful to understand what kind of automation is possible these days when you work with technical services. The first use case for automation is duplicate search. Suppose you have a list of gift books like this. The file contains the title, author, publisher, year, and ISBN of the gift books. You might want to consider acquiring these books if they are not held at your institution. So you will need to do a duplicate search. But if the list is long, like 5,000 titles long, it will take months to complete the duplicate search. Here at Yale, we have developed a duplicate search program that searches the Yale Library catalog by ISBN. I'm going to show you how the program works. I will detail some steps behind the scene after the demo. This program requires a base spreadsheet that contains 5 columns: title, author, publisher, year, and ISBN in that order. For this demo, there are only 50 titles in the spreadsheet. You can execute the program by simply clicking the play button on each step. First, you upload a spreadsheet. It's added here. By the way, the spreadsheet is only temporarily stored in this page. It vanishes once you disconnect. Second, you run a program. You can easily track the process by looking at the progress bar. Once the program is finished, you can review the results. You can see 30 titles are already held at Yale. The remaining 20 titles may or may not be held at Yale. You will need to check those manually. Finally, you can export the results to a spreadsheet. Once you see the output file, on the left pane, you can click Download. Downloaded file should look like this. Now, I will briefly explain what was happening behind the scene. The program reads the ISBN data on each row from the base spreadsheet. If ISBN exists, it searches the Yale Library catalog by ISBN using Yale Library's own API. Even if your library doesn't have such an API service, it is still possible to create a program like this by web scraping your library catalog website. If the process finds an item by ISBN, it returns note, item's bibliographic record ID, call number, and its status, such as checked out, not checked out, lost, missing, etc. If ISBN doesn't exist in a row, which is the case for order materials, or the process didn't find any item by ISBN, it returns a note, check manually. This doesn't necessarily mean that your library doesn't own the item. It could mean that bibliographic record simply lacks the ISBN, or if the ISBN had a typo. You may still find an item by searching by title or author manually. While this program is not perfect and you still need to search for some titles manually, it drastically reduces the number of titles that require manual search. You only need to search for 20 titles manually instead of all 50 titles. So I think it is still meaningful. Another similar common use case for automation is to search for a cataloging copy for backlog materials. In the past, to find catalog records, our library staff used to pull backlog materials from the shelves, brought them to their desks, and searched for cataloging copy in the OCLC client. If the materials didn't have cataloging copy, they would place them back on the shelves. And in 3 months or so, they would check the backlog materials again, and again, and again. I found this work of finding catalog records very time and labor consuming, so I automated the process. Again, my second program also needs a base spreadsheet for backlog materials like this. Data includes LCCN, ISBN, OCLC number, bib record ID, and call number. The data comes from backlog records in the system, including order records and preliminary records, and is generated from the database. For this demo, there are 100 titles. This is the backlog search program. Just like the first use case, you can execute a program by simply clicking each play button on this order. First, you enter your WorkCat Search API key. Second, you upload a spreadsheet. Third, you run the program. Once the operation is done, you can review the results. Among 100 titles, 82 have catalog-ready OCLC records. Finally, you can export the results to a spreadsheet. Again, I will briefly explain what was happening behind the scene. The process checks to see if there is LCCN, ISBN, and OCLC number on each row. If they exist, the process searches WorkCat by LCCN first, using the WorkCat Search API. If no good records were available, then it searches for records by ISBN. If no hits, it searches by OCLC number. This process considers OCLC records with English cataloging language, encoding levels of blank, 1, 4, I, or M, all of which are considered better quality, and LC subject headings acceptable for copy cataloging. Now, instead of having our staff manually search backlogs, we perform this process and print the resulting spreadsheet so that they only need to pull materials that were ready for copy cataloging. Of course, there are some limitations. First, this search is exclusively based on LCCN, ISBN, and OCLC numbers in the preliminary records. So backlog titles which lack these numbers in their preliminary records cannot be processed at all. Some backlog titles still need manual searching for copy cataloging. Second, this process is not perfect. It could return the wrong records. it is still staff's responsibility to verify the accuracies of what is found. Still, I think this automation is useful as it drastically reduces staff's time and labor manually searching for cataloging copy. These programs are written in Python programming language on a platform called Google Colab. If you are interested, they are available for anyone with a Google account to use. Please check my GitHub page to try them out. Even if you don't know Python, you should be able to easily run these programs. If you have ideas for automation that would benefit the Japan Librarian community, but don't know how to create one, please let me know. Maybe we can work together. Thanks for watching my presentation. Please contact me if you have any question or comment.